Good morning, guys. Anjani Kumar here, dealing instrumentation subject for a final year electrical students. Alright, so in a last session, we discussed about a single slope digital voltmeters, right? So we are discussing about the concept of dual slope or integrated type digital voltmeters, right? So in a last session, we completed how the single slope digital voltmeter will work, right? So it will take 5 to 10 minutes for our previous session. So with that you will get a clear idea about how the dual slope will work, right? So I just want to explain briefly what we completed in the last session, right? So dual slope integrated or integrated type digital voltmeters, right? Right. So we can explain the dual slope means it consists of two slopes. We can have a single slope dBm. We have a dual slope dBm. Right. So whatever the drawbacks in a single slope that can be overcome with the help of dual slope. So what is the drawback means whatever the output voltage which depends on resistor and capacitor here. Right. So whenever your output voltage depends on a resistor and capacitor means, so due to aging there will be a drift in a resistor and capacitor, right? Due to that, whatever the output voltage, we will get an error or a wrong output voltage, right? So that is a main drawback. So this can be overcome with the help of dual slope DVMs. So in this, so whatever the output voltage is independent of resistor and capacitor, right? So these are the more accurate instrument, but it will be a time consuming process, right? So whenever the electronic instruments that needs more accurate and more accurate, which time consuming may not be a problem for electronic instruments. So instrument that require accuracy, in that situation we will use these type of dual slope integrated type digital voltmeters, right? So we can use in digital multimeters, right? This will require a accurate voltage between the 2 points or a current or resistance, whatever it may be. So this can be implemented with the help of the concept of dual slope integrated type, right? So this is an indirect method, right? We won't directly convert whatever the analog data into digital form, right? So in that, whatever the analog data which is converted to time, proportional time, right? So whatever the proportional time which is converted to digital form, right? So this is not a direct method of approach. So whatever the analog signal, if you want to convert into digital form, first whatever the analog data which is converted to proportional time, alright? After that, whatever the proportional time which is converted to digital form. So whatever analog to proportional time, we require an integrator, right? So what is the device which can be convert whatever the analog data into proportional time, that can be done with the help of integrator. So that's why we are calling integrated type digital voltmeters, right? So whatever the time which is converted to digital form, that we require a counter, right? So the instrument which is nothing but the counter. So whatever the single slope or dual slope, the main components are integrator and counter. That's it. So that is a basic thing, right? So we discussed in our last session what is an integrator, right? I hope it's clear. I just want to explain briefly what is an integrator. You know about the circuit of integrator? Right? So we have a two inputs either V reference and V input, right? So V reference or V input, right? So both are opposite polarities, right? So if you go for minus polarity, you will get the positive output. If it is a minus, you will get the positive output. If it is a plus, you will get the negative output, right? So this is a resistance, this is a capacitance, alright? So you know the formula. What is the output voltage? So output voltage V0 is equal to minus 1 by RC integral 0 to T V in dt, right? So this is the formula for output voltage. So whatever the input, you will give minus V reference, you will give positive V reference, you will give plus Vn, or else you will give minus Vn. That's your wish. That depends on your output voltage. Alright. So now what is the function of integrator means? So how the change in output voltage, right? The rate of change in output voltage, how much time your output faster. So that is directly proportional to the input. That means rate of change of output voltage is directly proportional to the input that you are applied. Right? Certain time low, how much fast you will get the output. You will get the output that depends upon the input. Right? You will see here. So V0 is equal to, if you apply a minus sign to the input, then you will get the positive. We will see. If Vn is a minus value, you will get Vn by Rc integral 0 to T dt. Right? So both sides you will go for a differentiation. So then you will get, so dV0 by dt is equal to Vn by Rc, correct? So what means dV0 by dt? So that is equal to, this is the 1 by Rc is a constant now, is directly proportional to Vn. So from here you will say, right? So what is dV0 by dt? That means rate of change of output voltage. Right? How much faster my output voltage, that depends on the input value. That means whatever the input that you are converting into time based. Hope it's clear, right? So my first step is over. Your analog input, which is converted to time, proportional time. See what is a, per suppose if it is an per suppose this is an integrator minus plus. This is a ground. So this is R C. This is V0. Vn, either positive Vn or a negative Vn. It depends on your choice, right? Or else I am using minus V reference. Alright, whatever it may be, Vn or V reference. Anything you can take. Depends on your solution, right? So I have a reference value. Reference means a standard value. So that is a step input that I am taking. Alright. So that is whatever the input it is a step input. So that is my V reference value. If it is passed to the comparator, right? So then you will get the integration of step input. You will get the ramp input. So you will get the ramp input. Right? So what is the slope of this ramp input? We are getting a positive slope. So why we are getting a positive means V0 is equal to 1 minus 1 by RC integral V in dt, where V in, that is called minus V reference now. So that is called V reference by RC. So this is the slope, V reference by RC. So you will get the whatever the standard signal, which is a step signal, which is converted to a ramp signal. Right? So if you pass through the integrator, you will get the ramp signal. Now we'll see how it depends on it. You know, as per mathematical approach, you know definitely the rate of change of output voltage must be depends on your time. Alright? So that means what is dV0 by dt is directly proportional to V. So this is a very, very important. Now we'll see graphical approach how it will be. I have a different inputs. Right? So this is one input, right? I have much larger voltage, right? So I'm taking another input. So that is called second input. And I'm taking another larger voltage. voltages. So that is my, so these are the input voltages. Now I am giving these voltages to the integrator, right? So then what happened? Definitely what happened? So you will get the ramp signal. So this voltage is very less now. So that means it has smaller faster rate, smaller time. That means less speed and matter. So definitely this has the voltage that much high. That means more faster than this one. This has high voltage. That means more faster than this thing, right? But suppose if you assume one input voltage, a fixed voltage that you are assuming, right? So this is my input analog voltage that you are assuming, right? So whatever the analog voltage for a first given input, so how much time that required? This time is going to be required, right? For the second voltage, this time is required. For the third voltage, this time is required. So that means whatever the output voltage, that means whatever the giving input voltage, that may be depends on a time. If it is input voltage is very high, so that means it will take very less voltage. If it is smaller voltage, it will take smaller time. Like this, whatever the voltage which is directly proportional to time, whether it may be increases or decreases, whatever it may be. Now you are converting your analog voltage proportional to time, right? One step is over. Then what you should do, right? So then what you should do, the time which is converted to digital form, how it will convert it? So with the help of counter, right? You have a counter, alright? So the counter will count how many clock pulses during a given time. How many clock pulses? So this counter will display binary form, right? Who will give the clock pulses? We have a logic. We have AND gate, right? One end of AND gate will give the clock pulses, right? The main important another end, we will give the time, right? We will give the time. So what is the time? Time is directly proportional to the given analog voltage, right? But suppose for a given 10 volts analog voltage, you will get the time period is like this, right? This is the time, right? Here we'll see this time, this is high value up to this portion. So at this portion, this is high value and this is high value. So for AND gate, both are high. So definitely it allows the clock pulses. So in this period, how many clock pulses is there? So there are 1, 2, 3. 3 clock pulses. So AND gate will allow 3 clock pulses. The counter counts how many clock pulses. So there are 3 clock pulses. So then your binary will be displayed. If it is 100 volts, right? So whatever the analog data which is converted to time, so that much time is required, right? So this is one input of AND gate. So how many clock pulses that you applied at this time? So that means 1, 2, 3, 4, 5, 6 clock pulses you applied. So AND gate will allow 6 clock pulses. The counter counts how many clock pulses. That means that will be displayed on a LED display. There are 6. The binary data is 6. Hope it's clear. But suppose if it is a 2 volts, so what is the time? Right? It's like this. How many clock pulses that you applied? Only 2 clock pulses. So it will be displayed 2. Like this, whatever analog voltage, that must be depends on a time. Right? So whatever the binary data or digital form which depends on a clock pulses which depends on a time, right? Time which depends on analog voltage. I'll explain. Right? So whatever the digital form, it depends on clock pulses, right? How many clock pulses, right? These clock pulses, any clock pulses you have to send depends on how much time, right? So this time depends on analog. So that means whatever my analog data which is converted to digital form. So this is the logic, right? So first you understand the logic. then only you have to decide your circuit, right? So you will definitely, your own circuit you will be implemented, right? Because you are engineers, right? You have to analyze the logic behind this, right? If you analyze the logic, definitely you should build it. Now we'll go for circuit representation, right? So there are single slope, alright? So single slope, that means we'll draw the circuit, right? We have an integrator, right? So integrator which we will go to the comparator, right? So this is my input voltage. You said that I already two inputs is the V reference or V input, whatever it may be. You will give V input, you will integrate it, or else V reference you are going to be integrated, whatever it may be, right? Or C. So this is V0, right? So this is nothing but integrator output. Now we are having a reference, so that is a negative reference. If it is a positive, that is a negative, alright? First you should understand this block. After that we will enter to the logic, right? So whatever the V reference, so given V input is nothing but unknown voltage, that means analog voltage which you want to convert into digital form. Listen to me carefully. I said, what is the reference value? So the reference value will be minus V reference. So this is my reference value. If you integrated, what you get? You will get so what? You will get the ramp signal, right? You will see. Now, right? This is my input voltage, right? Now you just apply a ramp V reference. You just apply to integrator. You will get the ramp signal, right? Like that, the ramp will be close, right? You will see at this point, this is your ramp keep on increasing, right? That means your positive voltage, whatever the positive voltage, that is V in. Your positive voltage is nothing but V1. Your negative voltage is nothing but V0. Always up to this portion, whatever the positive voltage, which is greater than the negative voltage, right? So that means positive voltage greater than the negative voltage. That means V in greater than V0. No problem. Your comparator will set signal 1. It will allow the signal set to 1. At this point, we can call it as a trip point, right? So at this point, so that means at this point, what is? At this point, V in is equal to V0. Means V in is equal to V0. At this point, whatever a V in is equal to V0. So that means your comparator, it's nothing but a differential comparator now. So both inputs are equal. So what is the output? So definitely it will set the output as 0, right? So this period, so we can call it as a time, right? So this is your unknown voltage which is converted to time. So in the time you have to allow the counter. So now you have a logic here. You have a AND gate logic here, right? So whatever the AND gate will gives to the counter AND logic. So this will give the pulses, right? The counter will display binary data, right? See, now your V input which is greater than the V output, your one signal will to the AND gate. So both are high. So definitely it will allow the clock pulses to the counter. The counter will counts, right? So up to when the counter will counts, up to reaches if V in is equal to V out. That means at this point. So what happened? Whatever the comparator will set 0 value. So at this position, definitely what is the value here? 0. If one input is 0, another input is high, what about the AND gate? AND gate will set the 0. 0 means the counter. What is the counter? Counter will stop the counter and will display the binary value. Hope it's clear. Alright, so that is the whole operation of a single slope. So what is the output of this single slope? So you will get V0 is equal to minus 1 by RC integral V in dt. So whatever the V0 is directly proportional to RC, 1 by RC, whatever it may be RC. So that means whatever the output voltage must be depends on a resistor and capacitor. So that means due to aging, there will be a change in values of a resistor and capacitor if you use it for a longer period. So definitely the meter will reach the error value or a wrong value, right? So this can be avoided with the help of dual slope. So in the dual slope means single slope, you are integrating only one value. That means either reference value or an input value that you are going to integrate. But with the help of dual slope, you are going to integrate both the input value and the reference value. With that, you can eliminate the resistor and capacitor components. Hope it's clear. Let's see how the dual slope or integrated type DVM will work. Right, and now we'll see dual slope integrated type DVM. Or integrated type DVM. Right? Right? Like that, here also we have a 2 voltage. So that is called V input voltage. So that is nothing but unknown voltage. Right? Another input is a reference voltage. That is called fixed known voltage. Right? So you have a 2 inputs, 2 voltages, that is called V input, and that another one is called V reference. Right? Why we are calling it dual slope means which is having a 2 slopes. Right? So one slope due to integration of V in. Right? So there will be a one slope due to the integration of V in. Another slope that you are getting integration of V reference. Right? So there are two slopes will be present. The one slope is due to the integration of V in. Another slope is due to the integration of V reference. So that is nothing but de-integration. We will see how the integration will be de-integration. Right? You know that if one is positive polarity, another one is a negative. So both the voltages are in opposite polarities. If one is positive, another one is negative. If this one is negative, another one is positive. For suppose, if you want positive digital output, right? So if you want the positive digital output, your V in is positive and V reference is negative. Right? How? If you want a positive output, you just go for this logic. If you want a negative output, you just go for V in is negative, V reference is positive. Right? So this is the simple logic. Whatever it may be, you will get the digital form. If you want to negative digital form, you just give the both voltages must be in opposite polarity. Right? Hope it's clear. Why we are calling a dual slope means you have a both voltages are going to be integrated. V in is integrated and V reference is integrated. So both you are integrated. Right? Now the first we'll see what is the logic behind this one. Then only we will understand the total block diagram. Right? So first, whatever it may be, because this whatever the dual slope integrated type DVM is very, very important. So that's why I'm not explaining direct block diagram, because whatever the electronic instrument, whatever a digital voltmeter, digital multimeters, right? You are used in our laboratories, right? So these are depends on these type of principle. So that's why I'm stressing on this concept. right? If I explain like a block diagram representation, it will be 10 to 15 minutes is enough to complete the whole concept, right? So better to understand the logic behind this, right? Now, what is the logic behind it? Now, you know that the fixed voltage, that means whatever the standard voltage that you applied to integrator, you will get ramp value, right? Now, I have a standard input voltage. First I am going to integrate my input voltage, right? We have a standard input voltage that you are going to integrate it. So when input is integrated over a period of time, so particular time that you know, that is a fixed time. This is a T1 fixed, you know that time. So okay, I have an input voltage, I just want to integrate it that my input voltage. Now this is a time, fixed time. Now I decided that 10 minutes or 15 clock pulses that I need to integrate. You know the time is going to be fixed. Now I just want to integrate it, right? So you'll get the ramp signal like this, like this, like this, like this, like this, right? It would reach the maximum value of integration, right? So whatever the maximum value of integration must be depends on how much voltage that you are giving, right? So if you give the, you just understand the logic, that's it. After that you will explain the block diagram itself, right? I have an input voltage, I am integrating my input voltage for a particular period of time. So this is a T1 period of time, right? So I started my input, let's start integration, right? What happened? You are generating a ramp signal. So up to when it will reach the maximum, when how much voltage that you apply. If it is at 10 volts, it will reach the maximum here. If it is 100 volts, it will reach the maximum here. If it is 1000 volts, it will reach the maximum here. If it is 5 volts, it will reach the maximum here. Whatever the maximum integration, that depends on whatever the input voltage that you applied, right? So when it reaches the maximum voltage, your switch move to the reference value. We integrate చేసేసాం. After that it will reach the maximum value for a fixed interval of time, right? You started. After that, when it reaches the maximum value, you started your integrated to the V reference. You know that whatever the V reference, V input is a positive polarity, you will get the slope like this. You just assume both are opposite polarity, you will get the slope like this. So V reference is a negative polarity, that means you will get opposite to that. Now, so that is nothing but a de-integration. So integration, opposite polarity is nothing but de-integration. Now you are de-integration. Now you will see where a de-integration starts. Your de-integration starts from where the integrator will get the maximum value. From here your de-integrator starts. In the process of de-integrator, you will check. It will check when it crosses the zero value, right? So this is called de-integrated time. This is called integrated time. This is called de-integrated time. So during the de-integration process, you have to check whether when it will cross the zero time. When it will cross the zero. So this time, so whatever this time, it depends on how much time. So here you will it will cross the zero. So beyond that you don't have any signal, alright? So I will explain with that block diagram, you will clearly understand, right? So first what is meaning means, first you integrated the input, so you will get the ramp signal up to when it will reach the maximum of integration. When it will reach the maximum depends on our input voltage, right, for a fixed time. After that you don't know the time. After that, from where you get the maximum integral, after then you will start your de-integration. That means your switch enter into the reference position. So that is a negative. Negative means you are whatever the positive like this, negative will be in like this, opposite, right? So whenever switch enter the reference position, so what happened? Your de-integration will start. From where your de-integration starts, from where a maximum integration will occur. So from here your de-integration starts. Now we will check when it will crosses the 0. So that means when it will crosses the 0, that is my output. So when it will cross the 0, this here, this time, this is the time. This time which depends on what the maximum, from where your de-integration starts. This point is your de-integration start or the maximum value of integration. When the maximum value of integrations occur depends on magnitude of unknown voltage. Hope it's clear. So whatever the time which is converted to unknown magnitude of voltage. I hope it's clear. Alright? That means, so whatever the de-integration time is there, na time, which depends on what, where your de-integration start. Where your de-integration start. And this de-integration is nothing but where you get the maximum value of integration. Right? So whatever the maximum value of integration, when you will get the maximum value of integration depends on your given unknown voltage. That means whatever the unknown voltage which you are converted to time. Hope it's clear. Right? So I don't want to explain one more time because it's a clumsy process, right? So try to understand logic behind this. Nothing is there. First, I have a bean. I just given to the integrator, right? For a fixed time. Sir, you know the time. So our time work, I need to integrate this one, right? For a fixed time. So this is a fixed time, right? I started my integration, right? It will reach up to here. So ఎప్పుడు అక్కడ రీచ్ అవుతుంది, it depends on your unknown voltage. If unknown voltage is high, so definitely it will like this. If unknown voltage is like this. Alright? So after that, when it reaches the maximum value, your switch will be moved to the reference position. So reference is a negative one. Okay? Negative means it is opposite polarity. So if it is integrator, that is nothing but de-integrator. That is nothing but de-integrator. Now we'll start a de-integration process. This is a time t, fixed time. Right? When it started, you will see when it crosses a 0. So this time, that is my output voltage. That means this time, which depends on from where your de-integration starts. If your de-integration starts, you may be time like this. Here, you may be time like this. This time will be vary. It depends on where the de-integration starts. So what is this point? The maximum value of integration. When you will get the maximum value of integration depends on your unknown input voltage. That means my unknown input voltage which is converted to time. Now you know in this time how many clock pulses that you apply. So that is calculated by the counter. The counter will display binary data. Alright? Simple logic. So V is directly proportional to T, then T is directly proportional to digital. My unknown voltage is converted to time. So this time how many clock pulses that you applied? So that can be counted by the counter. The counter will display. Now we'll enter into the block diagram. So if you know the logic, it will be very easy for you. Right? First I have an integrator. Sorry, this is a capacitor. Right? We have a B input, right? So this we have a B reference, right? I have a switch, right? I have a switch or C. Now we have a logic. Logic state. So after that you have a AND gate. So here you apply clock pulses. From this you have a counter. Counter will counts. It will give the binary display. Right? So, like I said earlier, you have a two inputs. One is V input and V reference. If it is positive, you'll go for a negative. If it is negative, you'll go for a positive. Now I am taking the positive input. If it is a positive input, I just take it as a reference as a negative. Hope it's clear. Right? So this is a simple block diagram. So that is nothing but a comparator or a buffer. So I don't want to explain all this. You know, this is an integrator. So this is an logic gate, AND gate. This is a counter. This is a binary display. And this is a control logic. See, the first. So I am, whatever the input, that is nothing but analog input. Right? So which is given to the integrator. Right? So that is a positive. Then you will get the output as a negative. So that means B0 is a negative value. Right? Hope it's clear. So what is my output voltage? V0 is equal to minus 1 by RC integral over a period of time. You know the fixed time. I said earlier, you have to set a fixed time. Fixed time. Right? You started integration for a fixed time. So 0 to t, that is nothing but integrated time. So V in dt. So V in is a constant value. So minus V in by RC t. Right? So dt, integral 0 to t dt, you will get V0. Right? So now you start your integration. So integration, keep on integration. Right? It will reach us the maximum value. So now when it reaches the maximum value, that means you will get your positive slope. So that means you will get, but suppose this is a negative na, which is given to the inward comparator is there na, then if keep on moving, if you are negative and this negative, you will get the positive signal here. That means you will get the positive. Right? So this negative and this is negative, you will get the positive. So that the keep on your integrator start increasing. So if you get the positive, that means you are getting a maximum value. Alright? So when you will get the positive, so then what happened? Your switch, you will set a signal. That is one other control. When it will reach the positive signal, the comparator will send a signal to the logic. So here it will send a control. So it will move to this one. Alright? So whenever it will having a positive slope, that means you will get a positive value. That means you are getting a maximum value. So then it will send a signal to this one and it will send a controller. You have to switch the position to V reference. Right? Okay, my V in integration is over. You have to shift your position to V reference. Alright, now your V reference will start. So the maximum value of integration will depends on given input voltage. Alright, so when the switch shifted to V reference, so then what happened? So whatever the voltage that the capacitor is going to be charging now, input vachinappudu the capacitor starts get charging. When it will gives to the negative voltage, your capacitor is going to be discharged. Right? Both are integrated. But how it will process means the capacitor starts discharging. Alright? So that means a de-integration process will take place. When a de-integration process takes place, keep on increasing. Keep on moving. So when it crosses, here it crosses. Here at this point, whatever the output voltage of V reference output voltage 0. If V reference output, that means this voltage is 0. If this is 0 and this is 0, so what about these two are a differential comparator? Alright, see, your de-integration starts, your switch position to V reference, right? Your de-integration starts. Whenever the de-integration starts, so what happened? Whatever the de-integration starts, it will send a signal to the logic. It makes this one is high. Right now, your unknown voltage period is starting. Whenever switch position to V reference, it will send a signal to the control logic and make your AND gate high. Right, so now it's keep on increasing, and keep on increasing means the keep on signal clock pulses will go, keep on, the counter starts counting like this. Whenever it crosses the zero, right, whenever it crosses the zero, what about my reference voltage? Output is zero. So both comparator, both inputs are zero. So that means both inputs are zero. What about the output? Output is zero. So it will make the logic gate, it will make the logic low. When AND gate is low, it will stop the clock pulses. The counter will stop the counting and result will be displayed. Right? So this is the time period. In this time, how many clock pulses that you applied? So that can be displayed on the screen. Right? I just want to explain one more time. So initially, switch is at V in position. That means my integrator start integrating. You will get your output voltage. Right? So when at the output voltage, you will get a maximum value. That means you will get whatever the maximum value. So this is your output voltage. Right? So whenever it got the maximum value, the logic will send the controller. Controller will say, okay, you have to move your position to V reference. So then V reference, that means V reference starts integrating. Means it's the negative, means it starts a de-integration. In that period, you have to check whether it crosses the zero. So up to that, when it crosses the zero, the signal, whenever position to V reference, your control logic will send a gate to the high. So that means it keep on allowing a clock. Keep on high. So the clock pulses is going to be entered into the counter starts counting. So whenever it crosses the zero, see, you will get the zero value here. So that means both comparator, both inputs are zero. That means whatever the logic is low, then AND gate will stop and counter will stop and will be displayed. So what about the output here? So V0 is equal to V reference by RC. So T downtime, de-integrating time, whatever it could be, it's an integrating time. So if you equate, both voltages are equal. How much voltage that integrator capacitor charge, that much voltage is going to be discharged. Right? Both the voltages are equal. From here you will get V in by RC, T integration. So V reference by RC, T de-integrated. Right? So these RC get cancelled. You don't have any RC component over here, output voltage. Right? That means right? So that means V in T is equal to V reference T de-integrated. Right? So where T de-integrated is equal to V in by V reference into T. Right? From here, this T is fixed, this reference is fixed. Right? So whatever my downtime, that means de-integrated time, depends on your input voltage. That means V input is directly proportional to T de-integrated. So that's what we discussed here. So this is a downtime which is directly proportional to the given input voltage. In this time, how many clock pulses that you applied, it can be counted by the counter will display. It's simple. Whatever the output voltage that you are having, that doesn't have any RC components. That means you are eliminating the aging effect. I hope it's clear how it will work and why we are calling this one as a dual slope, because you are integrating and de-integrating both the input voltage and reference voltage. You are integrating. Alright. So now what are the advantages and disadvantages? You know everything. So what is the advantages? Right? It is more accurate. more accurate than any other DVMs, right? Which is more accurate than any other DVM, right? So more resolution, right? So whose output doesn't depends on a resistor and capacitor, right? So it's a simple in construction and simple logic, right? And what is the disadvantages, right? It requires more time consuming, right? So integrator will have some problems with integration process. So these are the advantages and disadvantages. Simple, you will tell that all the advantages and disadvantages, right? So this is about the total concept of dual slope or integrated type digital voltmeter. So we discussed about why we are calling a dual slope. So what is a single slope? What is the drawbacks of a single slope? How it can be overcome with the help of dual slope, right? And what is the logic behind a dual slope? And what is a block diagram representation and the operation that we discussed with neat and clear, right? If you have any doubts, feel free to ask me. Definitely I'll rectify, right? Thank you for now. In the next session we will discuss about the continuous balance type digital voltmeter, how it will works, right? Thank you for now.